Alright, so in this video I'm going to be talking to you about prime factorization. Now it's important to know kind of the background words there. So when we talk about factors, right, factors are numbers that we multiply together to get another number. So an example of some factors would be I could have 2 times 3 equals 6, and we would refer to both 2 and 3 as factors of that number. Another way to think of factors means that I could take a number, let's say like 12, and I could divide it by 6, and I get the answer 2, where there is no remainder. And so because I can divide 12 by 6 evenly, I know that 6 would be a factor, and the answer 2 would also be a factor. So we can kind of think of it both ways. Okay. Now the word prime really means a number whose only factors are 1 and the number itself. So some examples of prime numbers, something like 11. The only way I can get 11 through multiplication is by writing 1 times 11. There are no other factors for 11. The only factors are 1 and the number itself, 11. Okay, another prime number would be something like, we could say 29. The only factors of 29 are 1 and 29. There is no other multiplication I can do to get 29 where I'm using whole numbers only. So decimals don't count, whole numbers only. Now there is one even number that is prime. 2 is a prime number because we can write that as 1 times 2. There are no other factors. And we do not consider 1 to be a prime number. Okay, 1 is its own special number. It is not prime or composite. So 1 is separate. All right. So when we start looking at prime factorization, what that is it's just writing a number as a product of its prime factors. Okay, so we've talked about this a little bit in class, but that would be something like the number 12. The way I could write that is I could write that as 2 times 2 times 3. And I have written it as a product, so that means an answer to a multiplication. And all of those factors that I wrote there are prime factors. So 2 times 2 times 3 gives us 12. And so what we're going to do is look at how to take a number and figure out what its prime factorization is. Okay, so I'm going to look at this number 24, and I'm going to find the prime factorization of 24. And so my first goal is to think about what can I split 24 into, and I also want to try and pull out a prime factor every time, and sometimes it's easier than others. So this number, I can see that I have a prime factor of 2 because 24 is an even number. So that means I could split 24 and I could write it as 2 times 12. And that's handy because 2 is a prime number. So usually once I hit a prime number, I circle it or put a square around it. Okay. In some textbooks or some other examples, you might see them continue to bring that 2 down. I just think it looks messy. So I like to, once I find a prime number, I like to put a circle or a square around it. Now because I put that around the 2, I can't break 2 into anything smaller. The only thing 2 could break into is 1 times 2. And it doesn't make sense to do that, because if I break it into 1 times 2, well then I could break that 2 into 1 times 2, and then that 2 into 1 times 2, and then I'm doing that forever and ever and ever. There would be no stopping. As soon as I have something that the only thing I can do is 1 times that number, so as soon as I get something that's prime, I put a circle around it or a square around it and I stop. Now, looking at 12, I can break 12 into 2 other factors as well. I could split 12 into 2 times 6. And when I look at that, now 2 is another prime factor. So I'm going to put a box around it. Looking at 6, 6 is still composite, meaning I can still multiply 2 things to give me 6. So I'm going to break down 6 even further and write it as 2 times 3. Well, 2 is prime, so I'm going to put my box around that one, and 3 its only factors are 1 and 3, so it is also prime. So my prime factorization for 24 is now simply writing out all the different things I put a box around. So if you see, I have 1, 2, 3 boxes that have a 2 in it. So in my prime factorization, I need to have 3 2's written out because there were 3 2's that came out as prime factors. And then I've got that 3, so I would write my prime factorization of 24 as 2 times 2 times 2 times 3. If you go a little bit slower, 2 times 2 is 4, times 2 gives us 8, and 8 times 3 is 24. So we've taken 24 and we've written it as a product of all of its prime factors. Now you might be saying, well, there's another way I could have done 24. And there absolutely is. The fun thing about prime factorization is everybody could do it a little bit differently. So I might have said, well, 24, I can't find a prime factor, but I know that 4 times 6 gives me 24, and that's true. But neither of those numbers is prime. So now, if they're both composite numbers, which means I can still multiply two things to get that value, I got to keep breaking these numbers down. So 4, I could write as 2 times 2. Well, those guys are now both prime. And 6, as we saw in the last slide, I could write as 2 times 3. Those are both prime numbers, so we put a box around them. And once again, 24 is equal to 2 times 2 times 2 times 3. It's still the same prime factorization, even though I drew a different factor tree or prime factorization tree. Okay? I could do another one. What if I said 24? Well, I know that's the same thing as 3 times 8, because now I'm taking out that prime factor of 3 right away, and that works. And then 8 is still composite, and I can split it into 2 times 4. That 2 is prime, so I put a box around it. And I know 4 splits into 2 times 2. And so I put my boxes around those. Again, 24 is still equal to 3 times 2 times, oops, that one, my pen didn't pick up off the page. It's still 3 times 2 times 2 times 2. Now this does look a little bit different, only because I just put the 3 at the front. Remember, multiplication is commutative, so it doesn't matter whether my 3 is at the front or if I move it to the end. As long as all I'm doing is multiplying, they can go in whatever order I like. And let's check. 3 times 2 is 6, and then 6 times 2 is 12, and 12 times 2 is still 24. Now normally we do like to have our smallest prime factors at the front. Okay, so it is probably best to move our 2's to the front and have the larger prime factor 3 at the end. But we're certainly not wrong if we write it this first way. And the two ways are equal or equivalent. So let's try another number. Okay, let's try something like 36. Now again, lots of different ways to do it. Doesn't matter which way you do it. I, for some reason, always like to just say, my number's even. I'm going to break it into 2 times 18. I don't know, I find it easier to find those simple prime factors. If the number's even, I know I can cut it in half. Now I got 18. 18's composite, and I can write that as 2 times 9, because again, 18 is even. So I know I can split it in half. 9, I know I can write as 3 times 3. And those guys are both prime numbers, so they get a box around them as well. And so I could write 36 in its prime factorization as 2 times 2 times 3 times 3. I just write out all the numbers that are in one of those green boxes. And again, you could have a prime factorization that looks totally different than mine, and that's okay. Prime factorization of 84. So as the numbers get bigger, still works. Again, I can see 84 is even, so I'm going to cut this number in half. I'm going to pull out a factor of 2. 2 times 42 gives me 84. I'll put a box around that 2 because it's prime. 42, okay, that one's 2 times 21. Okay, 2 is prime. But 21, I can split. 21 I can split into 3 times 7. And so now my prime factorization is 2 times 2 times 3 times 7. 7 is also one of our prime numbers. The only way I can get 7 is by going 1 times 7. So let's say I had something like 7,500. So if I was to start off by just splitting this in half, because I can see the numbers even, yes, that's going to work, okay, but I'm going to have a lot more work to do. Because I have to work a little bit harder to kind of split a number in half that's this big. And so I'm going to try and look for some shortcuts. Now, because I know this number ends in 0, I know I can divide it by 10. And actually, because this number ends in 0, 0, I know I could actually divide this number by 100. And we actually, sometimes you'll hear people say, instead of 7,500, we might actually call it 7,500. That definitely means that I can split it where I've got 75 times 100. So I don't have to pull out a prime factor every time. And remember, if you haven't taken a prime factor out, then just keep splitting your composites. So now when I look at 75, I know 75, I could write that as 3 times 25, right? It's like 75 cents. It's like having 3 quarters, right? 3 25-cent coins. And 25 can split then into 5 times 5. Now you can see that I've got a lot more prime numbers going on here than I had previously. Okay? Now I'm going to take 100 and I'm going to split 100 into, I don't know, let's say 2 times 50. I can see 2 is prime. Okay? And then I'm going to split 50 into, I don't know, let's say 5 times 10. You can see I'm kind of not following any pattern anymore. I'm just splitting numbers into factors that I know work. Okay, it doesn't matter what order you go in as long as you get all the factors. So now I've got green boxes kind of all over the place. So let's start sorting things out. Okay, so I'm going to say 7,500 is equal to, now I'm going to take care of all my small primes first. So I'm going to find all the 2's. So I've got a 2 here, so I'm going to write that one down. And then I got another 2 here, so I'm going to write that one down. And then I don't have any more 2's. So the next smallest number is a 3. So I'm going to write that one in. And, well, in the rest of my green boxes, now I just have 4 5's. So I'm going to make sure I write down 1, 2, 3, 4, 5. So even though the number was really big to start with, I can still break it down into its prime factorization. And the prime factorization of 7,500 would be 2 times 2 times 3 times 5 times 5 times 5 times 5. That will give you 7,500 or 7,500. Type it into your calculator and try it out. So all prime factorization is taking a number and breaking it down into smaller and smaller factors until we can't break those factors down anymore because those factors themselves are now prime. So that's prime factorization.